Hello and welcome to another side episode of the GTK4 slash GObject tutorial series. In this episode, we're going to talk about asynchronous tasks using GTask with Glib2, GObject, and GTK using an API called GTask. But before we do that, I want to show you the kinds of problems that you can run into if you try to do a task that takes time to do in a function call, but don't deal with it in an asynchronous fashion. So let's pull up our first example. It's called GTask0.c. So I won't walk you through all the code. It's pretty straightforward. It sets up a GUI. And what we want to do is we want to click our Click Me button and say sleep in progress on the label. Then we want to sleep for 10 seconds. And then when 10 seconds is done, we want to set the label to say sleep done. And we want you to be able to click the button again. Looks simple enough, but watch what happens here. We make GTask 0 and we run it. What we think is going to happen is click me and it says sleep started. But we do that and the GUI locks up and it's not responding. And we're going to in fact get a dialog box right now on the screen right there saying that the application is not responding. But then when the 10 seconds are up, it says sleep done. We never got our sleep in progress message, and the click me button is activated again. And so what happened was GTK runs in the main thread of the application to update and render the GUI. But if we sleep in the main thread, if you think about a rendering of a GUI being I'm just picking a number out of my hat, 60 frames a second, let's say, you've got 16 milliseconds or less to update and render each frame. So if we're sleeping in the main thread for 10 seconds, that's going to be a problem. So one way to tackle these kinds of problems is to use something called GIdleAdd, which if you read this article by Emmanuel Bossi, lazy loading using the main loop, and you could just Google for that. Actually, I'll try to put a link in the show notes. What this is trying to tackle is the issue of it's trying to create a list store and add just so many items to it that it takes too long and could block the UI. So he breaks it down and he uses the main loop to add those items to the list one at a time. Whenever the main loop has basically spare frames that it can spare, basically. And so that's great if you have a small task that takes a millisecond, let's say, to do. But when you add them all up, it's going to take too long and it's going to block the UI. But in our case, we have a 10-second operation that, no matter how you could break it up. The only way you could do this using the GIdleAdd methodology would be to do the math in your, manually and figure out, how many seconds multiplied by some tiny number is going to work out to 10 seconds, and then use GIdleAdd to break that operation up. But it's cumbersome. And so I'm going to show you how to use an API called GTask to use what's called threading to spawn a new thread and do the 10-second operation in the new thread, and then report back to the main thread once that's done. So then we're going to look at our next file called GTask1, and you'll note that we're using just quick side note here. We're using the glog domain macro so that if we use the gdebug macro, which we do a couple of times in our program, we have debugging messages enabled. We can ask only to receive those debugging messages so that we don't get a whole whack of Glib2, GTK, etc. debug messages. So how do we do it? Well, you recall that previously in our activate function we connected the clicked signal to a button clicked callback. We're still going to do that, except now we're going to do things in a different way. We're still going to set the widget to be insensitive and say sleep in progress, but then we're going to create an object called a GTask, and we create it using GTask new, and it takes a pointer to the source object, which in this case will be our label, I believe. Yes. a cancelable object, which for now we're gonna keep as null, but you'll see soon enough why long term you don't want to keep doing it as null. But just for now, we're going to have it be null. And then you provide a GAsync ready callback, which is a callback, which that concept you're already familiar with. But this callback will be run when the task, in this case the 10-second operation, is done. That's when the callback will be called. And then you can have callback data to provide any user data that you'd like to the callback. I think in this case we're passing the button, but maybe a little bit of a spoiler alert, or if your mental spidey sense is going off of it saying, this could get a little bit tricky if we need to manipulate more objects, you'd be right. And you're going to see later on why we're not going to keep doing that long term. But for this simple example, we're going to go ahead and do it. And then we're going to run, we call this function called GTask run in thread. And what it wants is the task itself. And it wants a task func, a GTask thread func. And if you look at what that is, the prototype is right here. It takes a task, source object, the task data, and cancelable. So in this particular case, we're only going to be concerned about the task and the source object. We haven't passed any task data, and we haven't passed the cancelable. So that's what we'll be concerned with in the thread func. And then it sounds a bit counterintuitive, but we destroy the task, or we drop our reference is probably the best way of explaining it. We don't destroy. We drop our reference on the task because you see that we created it here, right? And in order to be somewhat convenient for us, GTask run in thread, although it's kind of structured like a regular object method that wouldn't take a ref on its own object, in this case it does, because it needs to make sure that the task stays alive while it's actually happening. So this allows us to destroy or to drop our reference on the task. So just bear in mind, GTask run in thread takes a ref, so you can drop your ref at this particular time. So let's go to the task thread func. So now you'll see that it maps the prototype that we just looked at. We're not yet going to actually utilize the source object, but you can see that these items would be passed to us. So we're going to still sleep for 10 seconds like we did before, and then we're simply going to provide a return value to the task asynchronously. And in this particular case, we're going to return a Boolean to show that, yes, the task was successful. And so that will then propagate to the actual callback function that we provided, which is the task ready callback. So when the 10 seconds are up, this callback will be called in the main thread. So the task thread func runs in a worker thread, but then the task ready callback runs in the main thread. And that's important. That's important because here we can do things like manipulate the label, but you'll see later on we cannot update the GUI in the regular fashion in the midst of the thread func. Okay, so just keep that in mind for later. So we're gonna do a few assertions here. I find with threaded code, I like to put a lot of assertions in because things can go awry very, very easily when you're doing threaded code, and things can explodiate, and we don't want that. So we're gonna do a number of assertions here. Now we're gonna set the sensitivity of the button to true. The return value of the asynchronous operation, which we told it was going to be true once the 10 seconds were up, we're gonna receive that return value here now that we're back to the main thread. And then if the ret val is true, which we anticipate it will be, we can't really at this stage think of a way that it would not be, the label will be set to sleep done, and otherwise it's going to be set to sleep failed. So then at some point the GTask API will destroy the task itself, because we already dropped our reference on it way back here. So that's basically the way it works. Let's try it now. Make GTask1, and let's run it in GDB. G messages debug is equal to, actually I forget what I called it, GTask-demo. -demo GDB GTask1. Let's run it. Okay. So sleep hasn't started. So now we click me. In sleep in progress. So you see now this is working, and the GUI is still alive. You can see that if we hover over cancel, that button doesn't do anything yet, but it still is operational. We haven't blocked the main thread, and we don't get that not responding message anymore. And now the 10 seconds are up, and the sleep is done. And if we wait a second here, you see all these new thread messages. Now that our thread has completed, at some point, and it doesn't happen right away, but you see right here, the new thread that was spawned by the GTask will destroy itself. And that's, so you don't have to worry about that. And then we can close the window and everything's all kosher. So let's iterate upon that a bit further. So let's take a look at gtask2.c. So we iterate now upon the first one, but you remember when I was telling you about how passing the label and the button as user data is going to be very limiting. So now we're going to actually create a customized widget to keep everything a little bit cleaner. For now, we're going to keep it in one file. Demo. We're going to call it demo widget. It's going to have the box, the label, the button, the cancel button, etc. We're going to define the widget here. Nothing surprising here. We've seen all this kind of code before. So the only real difference is that we're going to create the task. Nothing's different here. And then in the thread func, we did make one further change that's not related to the customized widget, which is that we've now broken up the task into 10 1-second tasks. So we're still going to sleep for 10 seconds. But if you think about it, you can't, like, there's no way to just tell a function that's running in another thread to just stop. You know, it's just not, at least not that I know of, or at least not cleanly. So we need some way of monitoring within our own thread function that's going to run synchronously and take time to do, that at some point we might want to look for some kind of hint to terminate ourselves. For now, we're not actually doing that, but we're just going to take a first step here to break this function up into multiple 1-second chunks, just to get the plumbing in place to maybe do something later on for that. But then nothing's really too different at this stage about how we are returning from the thread function. It's just that we've got all these self arrows in here now because we've created a customized widget. But I believe those are the only changes that we made here. We're just taking things one step at a time just to iterate on this and make things cleaner and cleaner as we go. So let's run GTask2 just to make sure that it is still working the same. Everything should still be the same. We click me, sleep is in progress, and after the 10 seconds is up, we should get the next message and be able to close the program. But I believe we haven't handled anything. You can still just close the window while the operation's pending, right? And the cancel button still doesn't do anything. So those are two warts that we want to work on. So let's take a look at the next iteration, GTask3. So now we introduce a new kind of an object called a GCancelable. And this is a very simple GObject in terms of how you use it, but it has a lot of checks and balances in place to make sure that it's thread safe, right? Which is very helpful for what we're trying to do here. And so everything should be the same here, except let's start from the bottom. Let's go up to our set up our threading. Okay, so here's a change. One moment, let me make a mark and go back to, we added to our widget a struct member to hold the cancelable object. And now in the button click callback, what we go ahead and do is, because the friendly manual TFM says that you don't, even though there's a way to reset the state of a cancelable, you typically don't want to do that. You usually want to, when you make an operation that's cancelable, you usually want to start from scratch and create a new cancelable object. So what we're going to do is clear our own cancelable within our struct and just create a new one every time you click the button. And it can create that new task when the button is clicked. But instead of passing null now to the GTask new constructor, we're going to pass the cancelable to it. And then everything else is going to be the same. We're going to run in thread as per usual. But we're going to add a check and balance now to the loop that breaks up the task into 10-second chunks. So each second, we're going to see if the task was canceled, and if so, we're going to return from the thread. We're just going to kill the thread function, basically. And so what this does is it will set the error of the task to say that the task was canceled, and it will set. You see how here we've got return boolean to true. It will basically do that, but except that it will return a false, which is what we want to show that the sleep didn't fully succeed. But how do we actually cancel the cancelable? Well, that's actually pretty easy. We already had a cancel button in place, as you see. Now we simply add another signal handler. We connect to the clicked signal, and we run the cancel clicked callback. And all we do is we see if the cancelable object exists on our structure, and if it does, then we just call gCancelable cancel on it. And then that will send the canceled signal, which is thread safe, and it will do it in a thread safe way. It'll basically emit what's called the canceled signal, I believe. Or it will set the state of the cancelable to be canceled. Let's not confuse ourselves. And it will do it in a thread safe manner, so that when we get way up to this guy, it will, in this thread, safely be able to return the task. And then, so what we expect will happen, and we might want to add a better handling to this in the future, hint, hint, is that when we cancel it, because we're going to return from the task false, we're going to simply get a sleep failed message. That's what we hope, in theory, will happen. So let's go ahead and do that. Make GTask 3. GTask, whoops, no, don't just run it in GDB. Okay, we don't want it debug info D at this particular time. So we're going to go click me. Let's just do it normally first, sleep in progress, and let's wait our 10 seconds. And this should work just the way it did before because we haven't canceled sleep done. So now let's go click me, but let's click cancel. It returned and it did say sleep failed. So that works, albeit not super gracefully. And let's see if, I don't recall if I added, no, I didn't add any handler yet to the close signal for the window. So you can still just close it in the middle of the operation, which maybe you want, maybe you don't want, which we'll get to in a moment. So you might wonder, like, is this the only way to do this? No, but there's a flag in GTask, and I just want to show you this flag real quick. But the best way that I could show it to you would be to go ahead here and add a debugging message. Just say function says hello. Fine. And you know what? Let's actually add the iteration number. So we're going to get the number of times that the sleep operation has happened. So what we want is, after you click cancel, to not do any more singular seconds anymore, and we want the thread to return, which is what's currently happening. But what if we did this? There's a flag you can set for GTask. It It's not really an object property, but it's a flag, and you need to use the subroutine to set it. So GTask set return on cancel, and I believe what the documentation says is, yeah, okay, so that allows you to automatically return control back to the main thread, and report that the oh my gosh, what am I trying to say? Report back that the operation would return basically a false with the canceled state being set to the error. So that sounds nice, but look at what happens when we do that. So what do I need to do? We need to pass it the task and a Boolean. Pretty simple. So task true, because that's false by default. Okay. Nothing in the documentation really tells you that that's the case, but just believe me, it is false by default. So let's do that. And let's try to be a little bit thinking to ourselves that we're going to give ourselves less work. Let's delete this this check here, because supposedly return on cancel should do this kind of thing automatically for us. So let's, but actually let's do it without that first. Sorry if I'm being confusing, but let's for now keep the debug message in place, and let's just run it. So you click me. Oh no, I must have screwed something up. Let's see. Oh, I forgot to actually, oh, I see. I commented out the wrong line, yeah. This is what happens when you try to talk and code at the same time, folks. I didn't mean to comment out the run and thread piece. That doesn't make any sense. I meant to comment out the return on cancel piece, because it doesn't make sense to show you that until we've shown you the normal way first. All right, I'll be all right. Let's try that again. So we click me, func says hello, and if we click cancel, sleep failed, and we don't get these messages anymore because we truly canceled the thread. That's fine. So now let's try the return on cancel flag on, and let's comment this guy out. We'll keep the debugging messages in place. We'll run it. So we're going to go click me. It's going to start doing its thing. We can click cancel and it will say sleep failed, but you see the task keeps actually going. And the documentation does say that this is the case. What it does is it just lets your thread silently run in the background, and then it will return, and it will terminate kind of on its own. But for our purposes, as you can see, we'd rather actually stop the operation itself. But the return on cancel can be good if you just have no way of ever interrupting the operation, or you have no way of breaking it up into smaller chunks. It just has to do its thing, but you might want to just return control back to the GUI. If you know what you're doing, then you can use that flag effectively, but for our purposes, that is not what we want. And in fact, we could even just be explicit right here and make it clear we don't want that. So if we go, just to make sure for posterity that everything's working, we'll run it one more time, and we'll just cancel the operation and make sure that the messages stop. They do. Okay. So that took me a little longer than I hoped, but thanks for bearing with me. So now we're going to do two extra things, and my little note to self, I don't need to follow anymore because we did that already. So, all right, let's just iterate on GTask 3 now and provide a better status message if the operation is canceled and disallow the window from being closed. So all we really need to do is add a couple of extra checks here. So in our task ready callback, instead of just saying if and else, we say else if, and if the error that is set matches the fact that that of a canceled operation, then set the message to be sleep canceled. So G error matches takes a const error star. It takes a quark for the domain of the error, and it takes a code that has to marry up with the domain for the error code. So this quark and error code respectively are baked into Glib2. So we can just simply use them. And so you can just simply treat this as a boilerplate line. And you don't, G-error matches is null safe. So you don't have to say if, error is not equal to null and the G-error matches. Like if the error is null, G-error matches will just silently not do anything. And so we don't have to add that redundant extra check. And we can expect that if the error is set, that the ret val will be set to false. That's just simply defined behavior in Glib2. So we don't need to add a bunch of useless checks to make sure that that's the case. Just simply if ret val, sleep's done. If not, and the error matches the particular error that matches with a canceled operation, we're going to say sleep canceled. And if we just don't know what the heck the error was, we probably will never see this. You could even say G unlikely here. Whoops. If you wanted to optimize that, we're not going to bother. Then we're going to set the text. We're going to do everything. We're also going to use gclear pointer to free the error if if necessary. You could also use an auto pointer, but we're just not using auto pointers in any of these examples, just to explicitly show everything that we're doing. So make sure that you do that, otherwise you could get a memory leak. And then of course we're going to clear the cancelable object here as well, because that'll set it to null, and that will show that there's nothing pending any longer. Kind of redundant, maybe redundant in some cases, because we already call that in the button click callback, but there's really no harm in adding it in two places because we only own one reference on it, and clearing it if it's already clear is not going to do any harm. So fine. And then one other thing we're going to do is we're going to add a close request signal callback to the window itself, and we're going to handle that and say if the cancelable object is not null, then we're just going to say the operation's pending, you can't close the window. A couple problems you may see here is that you might not want the struct member, you might not have the struct member directly accessible if you break the program up, you break the widget up into a different file, hint, hint, as we'll do soon. So this is a bit of, this should jump out at you as a possible code smell, and it is, but we'll address that shortly. So now we should get a better message for the canceled operation, and we should not be able to close the window while the operation's pending. We're not really handling that in the latter piece in a very sophisticated way. We're just printing a debug message to the screen as an exercise, and we will never address that in these examples, by the way. As an exercise to yourself, you could work at that and maybe pop up a dialog box or pop up a toast or pop up a little status message somewhere else saying you can't close the window right now, or you could ask the user if they want to force the closing of the window. I leave that to you as an exercise. There's multiple ways you could tackle that issue. So we're going to run the program. Everything should be fine. What happened was, I think when I was writing my previous example, I kept our says hello debugging message in there, so we'll just keep it in it. There's no harm in it right now. Sleep done. So if we cancel, it should say sleep canceled now, as opposed to just sleep done. And if we try to close the window while the operation's pending, we're going to get our debug message to the screen saying you cannot close the window. And if we either cancel it or wait for it to finish and click me is activated again, we can close the window. So there we go. Again, iterating on what we're doing. Let's take a look at GTask 5. Now what we want to do is not only do things the way that we've done them thus far and show that the operation's pending and done, we want to show a progress bar now to show the progress of the operation. So what we do is we add a progress bar to our guy, our widget. We just add it to the box. Nothing too special goes on there. The way that a progress bar works is that it has a property called the fraction property, and that needs to be between 0.0 and 1.0 to show the percentage of the progress. And however you want to structure getting from 0.0 to 1.0 is totally up to you, but that's the way that it works. So we're going to, let's start from the bottom. So when the button is clicked, we're going to set the progress bar fraction to 0, and that happens in this line right here. Everything else should be mostly the same at this stage. But recall, and I made a very particularized note of this, you cannot update the GUI during the thread func. So you might be thinking, how are we going to deal with this? And I'll show you. So before I show you all this task data stuff, which is important, I'm going to jump straight over to the thread func. And you'll notice that we're not just calling GTK progress bar set fraction here, because this is the thread func. You cannot update the GUI directly in the thread func. You need to tell Glib2 that, look, there's an operation that we want to do in the main thread, so please do it when you get the chance. So the way that we do that is we have to use a function called gMainContextInvoke. And what that wants is, it wants a main context, a source func, which can only take one parameter, which is a G pointer, and then it wants a pointer to that data. So that limits us. So we need to work around that. If you pass null as the first parameter, it will do it in the main loop. So that's pretty convenient. But we need to give it the percentage and we need to give it the object. So we need to give it two things. So in order to do that, we do go ahead and set up a struct called the sleep task data struct. And in that struct, we simply provide a slot for the demo widget and a member as a double for the progress of the operation. And let's see, where do we create it? We create it in the button clicked callback. We create the task data using GNew0, which zeroes out the struct, and then we set the demo to a member to ourself, and we set the progress to 0.0 as a double. And then we use a special function called the GTask set task data. And what that wants is the task, a pointer to the task data, and a function to destroy the task data. So because we create the task data with GNew0, you just use gfree to free those guys, to free the heap allocated struct, basically. So we're going to pass gfree to the destroy notify, and then that will simply hand off that structure effectively to the thread func. And then the task data, we're going to now call it TD, just so we don't have two variables with the same name. And then we're going to pass that on, and we're going to not cast it, but we're going to declare here that our TD, which is a G pointer here, is really a sleep task data. And we're going to assert that that's not null, because if it is, we've screwed something up, because we need it to exist and we need it to have our data in it. And we're going to assert that the number of seconds is greater than 0. Don't recall if we did this before, but if we didn't, we probably should have, because just to make sure that we don't do something stupid if we change this value and have a divide by 0 operation. So we now are going to start the loop at 1 and use a less than or equal to check, simply because it just plays better with the progress bar, because it's fine to say 0 through 9 and count 0 as a number if you're just waiting 10 seconds. But if you want to show that now we're at, the 10% mark for the progress bar, 0 is not a very good number that plays nice with that kind of thing. So we're going to start at 1 now instead. Everything else is the same, except that the task data arrow progress is going to be set to the I divided by the number of seconds, which is the same as it was before. Or I'm sorry, we didn't do this before. It's going to be set to, this is going to act as our percentage. So basically we're just going to take I divided by the number of seconds. So this is why we have our G assertion up here now. Just to show that just to make sure that we don't accidentally do a divide by 0 operation right here. And then we're going to call this special gSource func in the main thread. What does the gSource func do? It takes our task data as its data. Again, you want to have lots of assertions in your in-thread related codes. We're going to assert that this is not null, and we're going to assert that the actual task data arrow demo is actually a demo widget. And then we're going to call from this function, which we know will be run in the main thread, we're going to set GTK progress bar set fraction to the progress of the task data. And then we're going to call gsource remove, which just means don't keep running this function over and over and over again. Take it out of the main loop once you run it one time, which is what you want to do. Otherwise, it's going to not really work very well. And you don't want to accidentally make this a static void, because then you're going to run into undefined behavior. So make sure that the compiler will probably yell at you, but if it doesn't and you get this far, just make sure that you do it right. Otherwise, you're going to get undefined behavior. Okay, I think that should be it. Yeah, so that should work. And just as a quick side note, where do we call our, when we do the main context invoke guy here, here's why I'm being so meticulous about this. If we naively run the GTK progress bar set fraction call here, I'm going to put danger, you can't do, like, here's where things get really, really messy. You could do that, and guess what? It would probably work. Maybe a 90% chance that it'll work. But it could also explodiate. It could also crash. It could also do something totally random and weird. And that's what's so dangerous about threading, because it's not like a fork where you get your own copy of all the memory. This is all operating on shared memory. So you could be updating the fraction property of the progress bar while GTK is in the main loop in the middle of doing like a paint operation or something. And you can get, and that could really disrupt what's happening in the main loop. So don't do that. If you do, you might not catch it for a while. And then when your application is just randomly crashing or randomly exploding in weird ways, you're going to be like, what's going on here? And then you're going to spend hours and hours trying to debug it. And then you're eventually going to realize that you called a GUI updating function not in the main thread. So this is why I'm being so meticulous about it. I don't think I made any changes. Let's just save and quit. After all that, let's make GTask 5. Hopefully I didn't screw something up. Let's run it. So we get our application. We click me, and now we're going to see a progress bar showing the progress of the 10-second operation. And once it is done, everything should be the same way it was before. Sleep done. You can run the operation again. You still can't close the window during the operation being pending. You can cancel the operation, and you'll note that it set the progress bar to be 100%, which is probably not what we want, but that's a minor thing that we'll maybe work on later. Now you can close the window. Everything's kosher. So I did indicate that accessing, for example, the demo arrow cancelable member of the struct was a potential code smell issue, and that was absolutely correct. So now we're going to break up the widget into its own files. So we have a demo widget.c, demo widget.h, and a main.c. So the main.c is really just a very simple stub that creates the window, creates now a demo widget rather than, well, I guess it did that before, but it does that. It includes the demo widget.h header file now. And so because the struct is defined in the C file and not in the H file, we can't access members of it directly now, which is, again, a good thing, because it allows for more modularity. Excuse me. So you'll notice now that we have, instead of saying if demo arrow cancelable, we created a getter. Let's just open up the demo widget files here. So we now have a property called the in-progress property. We create that here as a read-only property, and it's a Boolean. And how does it work? Well, we only define it in the get property because it's read-only, and we create a function called demo widget get in progress. And now we simply check to see if the cancelable object is null or not. And if it's not null, we return true. And if it's null, we return false. So pretty straightforward. So it's just done in a way that A is more modular, and B, if we change the implementation of what it means to be in progress, this function call here will still simply work just fine. So a little bit of a cleaner methodology. Other than that, everything should be the same. You can always look at the actual code in more detail on the GitLab repo. So let's just run it here to make sure that it works. And let's run main now through GDB. And everything should be the same. It's just that now it's broken up into more modular chunks. Programmatically, we can still cancel the operation. Everything's still the same. So that's fine. Now let's take a look at GTask 7. Make clean. Let's take a look at what we have here. So now we're going to do something kind of interesting. And I will say this. You could very well stop at GTask 6 and be like, I'm satisfied with the way this is working. But just as an exercise, we're going to make things a little bit easier to work with, in my opinion. Maybe you won't agree that it's easier to work with, but more generic. I think we can agree on that. So I'm going to open up the demo widget .c file here, the demo widget.h file here. So you'll notice now we've added a new property called the progress property, and I can agree that it's maybe not the best name because we have the in progress property and the progress property, but I'm not very creative, so we're just going to keep it the way it is. And this is going to be our own double property, a percentage from 0 to 1, the same way that the progress bar itself works with GTK, except this is going to be a read-write property, and it's going to be, so it has a getter and a setter, which are defined as demo widget get progress and demo widget set progress. And demo widget get progress simply checks to see if we're in progress, and if not, it will return a 0. And if it is in progress, it'll return the self arrow progress struct member value. And then the set progress function, and note that we're using gReturn if fail now as opposed to gAssert because this is public API. So we don't want, if somebody uses our public API and screws it up, we don't want the program to abort. We just want error messages to appear and for the function to return. So that's a bit of a difference there. So the set progress is going to do a basic return if fail to make sure that we are what we say we are. Ignore this for a second, I'll come back to it. This is not a typical thing to do, but it's something that I'm going to do just to make what I consider to be kind of a thread safe widget, which again is not a common thing to do, but I'm just going to show you how I did that in a moment. So the meat and potatoes though is here. Self arrow progress simply gets set to a clamped value between 0 and 1. So if somebody gives it a wild value, we'll just make sure that it's kept between 0 and 1. And we're going to notify by pspec that the property has changed. Simple. Now you may be wondering, well, how is this actually going to change the progress bar value? And that's a very good question. We're going to do something called create a property binding. And we're actually going to create two property bindings. I lied. 3 property bindings. So we're going to bind our progress property to the fraction property of the progress bar. So basically, whenever our progress property value changes, it will just go ahead and automatically change the value of the progress bar fraction property. So it will keep them in sync in a unidirectional manner. And then we're simply going to set the sensitivity rather than manually setting them. We're just going to bind the sensitivity of the button and the cancel button to whether or not the operation is in progress. Now, if it is in progress, we want to invert the Boolean for the sensitivity of the click me button, because while it's in progress, we want it to be the sensitivity to be false. So when in progress is true, sensitive will be false. And invert Boolean allows us to do that. And the gbinding sync create, I don't think it's probably necessary for this guy, but it doesn't hurt either. For this guy, it is necessary because the default property of a button is to be sensitive. And so we want, upon the creation of the cancel button, we want that to be bound right away upon creation to the in progress property of our guy. And so that's why we use sync create. I believe that if we didn't use sync create, the cancel button wouldn't immediately start off as insensitive until the first time the in progress property changes from beyond that. So it's a bit, as I think I've said this in a prior episode, it's a bit hard to tell sometimes when you should use sync create and when you shouldn't. It is, quite frankly, in my experience, a bit of trial and error. If you don't include it and things don't quite work right, you might want to try including it and see if it does work right. I'm just being honest. Sometimes that's my experience. Okay, so that's fine. And what else did we do? Oh yeah, let's go to the thread func. Actually, before we do that, let's look at the thread func. So instead of using let's not go with the thread func. Let's go to the button click callback. I'm doing these a little bit out of order. It's hard to remember sometimes the order in which I should show things. So we're not going to set task data anymore. We're going to do things in a more generic fashion. So we're going to pass, I believe here is where you would, no, that's where you pass the user data, which is not to be confused with the task data. So we're just not going to pass any task data to it anymore. We've deleted the whole notion of the sleep task data. That's gone. So we're going to simply get rid of that here, and we're going to run our function in the thread. But then instead of creating, instead of invoking manually a gsource func through our thread func, we're going to use a generic function that I created called util GObject set in main context. And what that does is it sets any GObject property you'd like by way of what's called a G value. And let's show you how that works. So util.c and util.h. So we'll come back to this in a second. That's a macro. And you saw it before, but I'll explain what it is in a moment. So let's start with this one. Util GObject set in main context. So it takes an object, a const char star string to the name of the property, and a G value to what you want to change the property to in a generic fashion. So what that does is, instead of having the task data that was specific to the widget and the progress bar, we're going to create a generic object set data structure in the util function that takes all the parameters that we just passed to our function call, the object, the property name, and the G value. And this is not a pointer. This is the actual struct itself going in by value to this struct. And then in the util GObject set in main context, we make sure that the object passed in is actually an object. We make sure that the property name passed in is not null. And then we create our object set data struct using GNU, and we just simply set the parameters to be what they are. And this is just simply to accommodate the fact that, again, a source func can only take one G pointer. And then we're going to simply set that GObject property in the main thread. And in a generic fashion, we're going to do that using the set in main context source func, which again just takes a G pointer to the data. We're going to assert that it's not null, and then we're going to use a standard GObject function, but we're going to do that in the main thread, which is GObject set property. Now, I rarely use this in regular code. I would usually use GObject set, which is better for C convenience, where you basically just pass you've probably used it before. You set names and values using var args. It's very convenient for C programming, but you can't really marshal a VA list very easily and pass var args to a gsource func. So you could it's probably possible to write some really gross code to allow you to do that, but we're just going to use G values. It makes our life a lot easier and simpler for these purposes. So really, all util GObject set in main context is a wrapper around GObject set property that does it in the main thread. So, you know, a little bit of not gross, but a little bit of like jumping through hoops, let's call it, to get here. But it's actually not too complicated. This stuff here, what's a little bit maybe not so nice about this API is that we have to use G-value to pass our information generically to the main thread using these wrappers. So, like I said, you might want to just stop at GTask 6 and say, I'm fine with this methodology. But if you want something more generic, this is just one way to do it. So how do we actually do it? How do we actually utilize this now? So we have to create a G value, and we do that right here in the progress updating portion. Call it progress G value. You always have to initialize a G value, which we do to a macro called G value init, which is just zeroing out the structure basically. What you used to do is you would do 0 before that macro existed. I was reading a Bugzilla report from like 2011 or something that said that this macro was added because some people were getting compiler warnings about unused or what do you call it? Struct fields that were not captured by the brackets or something really stupid like that, even though it's well-defined behavior in C just to do this. But this is more idiomatic now, so we're going to use the idiomatic methodology. Confusingly, after you do this with the G value init capitalized, in order to use a G value, you have to use lowercase G value init, which is totally different than uppercase G value init. Lowercase G value init says, okay, you G value, here's what I want you to be. And what it wants is a G value star, and it wants a G type. So we're going to tell the G value, we want you to be a double. And we do that here. And then we can call G value, G value set double to tell it what we want the valuation of that double to be, which is the I divided by a number of seconds. And then we pass that along to our helper function here, our utility function, to make sure to set the progress property of our guy to the G value of the progress that we want it to be in the main loop. Now you may wonder, why do we need to do this? Why can't, back in the util function, why can't we just pass the G value directly to the main context source function? Well, the problem with that is that we're passing by value, and so we're not in the same stack frame. When we invoke something in the main context, if we were to say create the G value somewhere in here, G main context invoke doesn't invoke that within the main thread in the same call stack. It's gonna, this scope is gonna return, and the G value if it was set here would be destroyed, and then you're going to get an undefined behavior territory. So we do need to create an object on the heap that carries all the data of that G value by value. There's other ways you could do it as well. This is just the way that I decided to do it. But just don't think that you can just pass the address to the G value here on the stack. That's not going to work. That's undefined behavior. So anyhow, let's go ahead and take a look at this code. Or look at the result of it, I should say. And now let's run the program through GDB. Everything should work approximately the same, except because of the way that we've used property bindings and our getters and setters and everything else, you might find a few small changes occur. So the sleep is done, and the cancel is not possible to click now. And if we click the click me, if we cancel the operation, it will just keep it where it is, which may be fine. And then it won't be reset to 0 again until the operation starts again. So, a few little tweaks that you could make as a result of the binding. You can make sure that certain properties are set at different times to make things look a little bit nicer, but that's pretty fine for what we're creating here in this demo. So now, last but not least, well, it is least in a way, because in the GTask 8, which is our final portion, all we're going to do is rework our demo widget to use standard Glib2 style async and finish functions. So if you take a look here at the documentation, typically you're going to see blah 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 underscore async and blah 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 underscore finish functions, and we don't have those in our program. So if somebody's using our API as public API, they might want to call our sleep function and do it in a way that they expect to have it happen, as opposed to it just being directly bound to the button click callback. So what we'll do is we will open up a couple of guys here. Main.c. No, I think all we need to show is actually the button. There's the button, the demo widget. So we've now created 2 additional functions: demo widget sleep async and demo widget sleep finish. So a typical async function will take the instance of the object, and you could have a whole bunch of other guys in here. As you can see, we're not going to go that crazy with our guy. We're just going to go straight to cancelable, callback, and user data. So this follows the typical Glib2 style async protocol. And so we've just moved things around a bit, and instead of doing things in the callback, we're doing things in the sleep async function. Now, because a idiomatic Glib2 async function allows you to pass your own cancelable to it, we're going to handle that situation. If somebody passes a cancelable to us, we're going to allow them to use their customized cancelable in the GTask. Otherwise, we're going to use our own cancelable that we have. So the operation will still be cancelable because we have our own cancelable, but if a user wants to plug in their own, they could do that. So everything else is approximately the same, except that instead of having a specific callback baked in, we allow the user to pass in the async ready callback that they want. And so that's fine. And so how do we incorporate that into our program now? Well, instead of, again, handling everything directly in the callback, we just call the sleep async function now, right? And we pass a callback to it called the task ready callback. But in the task ready callback, instead of grabbing the information from the GTask itself, we just simply call the finish function, which is more of an idiomatic Glib2 style function, and then we handle everything the same way that we did before. And the finish function, all it does is it calls the propagate boolean and passes it along the error pointer as required. So just a refactoring, really. Nothing really has substantively changed, but let's just make sure that it works. Everything should be the same. Click me, the sleep is in progress. Cancel it, it cancels. Click me, can't close it while it's running. Let's wait for it to finish, and then it should say sleep finished. It does. We can close the window now. Okay, so again, all the code will be on the GitLab repo, and if you've seen all the rigmarole that we had to go through, my statement from the beginning still applies. If you don't have to use threading, don't. Only do it if you really have to, and if you do really have to, you've got to be so careful. You got to make sure that you don't update the GUI of a GTK application in any thread other than the main thread, and you want to make sure, like I said, that you put a lot of assertions in place, because it's really easy to screw something up when you're doing threaded code, and you want to make sure that things don't explodiate, because things can work or appear to work for a while until they don't, and then things crash or things go wacky or things explodiate. Like I said, you don't want that to happen. So don't use threads unless you have to, and if you do, you got to be so careful. But hopefully this helps. That's all for today. This is Elliot Rathbone signing off. Good night and good luck.